Hi there, and welcome to this lesson. And this lesson we'll be doing basic algebra, okay? And on the basic algebra, we're learning to factorize algebraic expressions. And at this point, I would remind you to set the video to play in 1080p HD so you can see everything clearly, okay? And you can do so via the settings icon on the bottom right. And as the lesson progresses, if you have any issues at all, okay, if you don't understand anything, please feel free to get in touch, okay? You can do so via the course dashboard and we would be happy to help. So, let's get right into it. Now, factorization of algebraic expression. What is factorization? Okay, to understand factorization, we need to know what factors are. Okay, something called factors. What are factors? We get factorization from the word factors. So what are factors? Now, factors are smaller terms that can divide a given algebraic term. Okay, for example, if you have a term like 2x, now 2x can be divided by x, so I can say that x is a factor of 2x. If you have 4x squared y, all right, I can divide 4x squared y by 2xy. Okay, so basically I can say 2xy is a factor of 4x squared y. Okay, so what then is factorization? Now, factorization is a process of simplifying an algebraic expression using the common factors of its constituent terms. Okay, and let's just jump right into it. Okay, and we'll explain this. Now, consider this. So you have this term 14x squared y. All right, I'm going to break 14x squared y into its factors. Okay, and basically I'm going to have 2 times 7, i.e. the 14, times x, i.e. x squared, times y. Okay, so basically when you multiply these out, you get 14x squared y. Similarly, I have 7y squared. I'm going to break 7y squared into 7 times y. And I also have 35xy cubed. I'm going to break 35xy cubed into 5 times 7 times x times y times y times y. Okay, so basically these are the factors of the given terms. Okay, and now what we want to do is we want to find, we've been told factorization is the process of simplifying an algebraic expression using the common factors. Okay, so we're going to find the common factors here. All right, so what factors are common from 14x squared y, 7y squared, and 35xy cubed? I think we have sevens. Okay, so there's a 7 at the top, there's a 7 in the middle, there's a 7 at the bottom. So each of those terms has a 7 in them, so I can cross out the 7s. Okay, so we have 7. And is there anything common, any other factor common? We would have had an x, but there's no x in 7y squared. Okay, so x wouldn't work. But then I think we have a y, so we can cross out y. Okay, so basically the common factor here, the factor that's common between 14x squared y, 7y squared, and 35xy cubed, because I don't think there's anything else we can cross out, is 7y. Okay, and basically we can use 7y to factorize, that's what it's called, factorize an expression like this. So let's say we had an expression 14x squared y plus 7y squared minus 35xy cubed, i.e. this expression is made up of the terms that we just broke down a short while ago. So we can actually use 7y to break this down, and what we have equals 7y, okay, 7y open bracket, okay, or 7y multiplying we have 14x squared y. We simply divide 14x squared y by 7y, and we have 2x squared. Okay, and then we had 7y squared. We simply divide 7y squared by 7y, and we have plus y. Okay, now think of factorization as the opposite of expansion. Okay, so basically if I from the last lesson, if I told you to expand this, basically you'd have 7y multiplying 2x squared, and b, you would end up with 14x squared y. Okay, so b, but instead of multiplying out, we're actually dividing. Okay, so we're going in reverse. All right, and then we have 35xy cubed, and that would give us 5xy squared. When we divide 35xy cubed by 7y, we have 5xy squared, and that is pretty much factorization. Okay, you basically the opposite of expansion. Okay, when we're expanding, we're dividing, and now we're when we're expanding, we're multiplying out. Okay, now we're factorizing, we're dividing. Okay, so we're actually making the terms smaller. Okay, so if you have from the last lesson, just pretty much what I've been saying, if you had an expression like this, and you could expand this expression to get this new expression, 14x squared y plus 7y squared minus 35xy cubed. So this is expansion, and simply the reverse process is factorization, and that is pretty much what factorization is about. Okay, we're simply just reversing expansion using the factors of the constituent terms, the common factors of the constituent terms of a given expression. Okay, so let's do some examples. Okay, example one is a very simple one, and it says factorize the algebraic expression 2a plus 6. How do we go about doing this? Obviously, the first thing we need to do is we need to find a common factor. So with the terms we have here, we have 2a and we have 6. So we need to find something that would divide 2a and would also divide 6. And I'll tell you that that common factor is 2. Okay, because we can divide 2a by 2, and we can also divide 6 by 2. And then once you have your common factor, you simply go ahead and factorize. And factorizing 2a plus 6 with 2 would have 2 outside the bracket, and inside would have a plus 3. We simply divide 2a by 2, we have a, and we divide 6 by 2, we have 3. It's that simple. There really isn't much to it. Okay, and that's how you factorize an algebraic expression. Let's try another example. Now, example 2, and example 2 says factorize the algebraic expression ax squared plus 2ax minus a squared x. Okay, we want to factorize this algebraic expression, and just like we did in the last example, the first thing we want to do here is we want to identify a common term. Okay, identify a common term, and basically if you look at what we have here, a common factor, look at what we have here. We have ax squared plus 2ax minus a squared x. Okay, if you may choose to break this down, but I've been doing these for quite some time, so, and I reckon when you do this for quite some time, you'd be able to identify common factors by merely looking at the expression. Okay, and I'll tell you that my common factor here is ax. Okay, and basically because you can divide ax squared by ax, and you can divide 2ax by ax, and you can divide a squared x by ax, and that's pretty much what you'd go ahead and do. You simply divide all of them by ax, and you'd end up with this ax open bracket x plus 2 minus a close bracket. Okay, and that is how you factorize. Basically, you have ax squared divided by ax gives you x, 2ax divided by ax gives you 2, and minus a squared x divided by ax gives you a. Very simple, very straightforward. Let's move on to the next example. So example 3. And example 3 says factorize the algebraic expression. It's getting a bit more interesting now. 3a plus b, 3 multiplying a plus b plus x, open bracket, a plus b, close bracket. This looks interesting. How do we go about doing this? So just like we've done with just like we did with the previous examples, the first thing we need to do here is we need to identify a common factor. Okay, and the common factor in this case is actually quite interesting, and we need to actually understand before we go ahead and do so. Now, We have a plus b multiplying 3 plus a plus b multiplying x. Let me say this again. We have a plus b multiplying 3. That's one term. Okay? A plus b multiplying 3 is a term. Think of it as a term. Okay? And then we have a plus b multiplying x. What do you think is the common factor in this case? I say it again. I have a plus b multiplying 3, and then I have plus a plus b multiplying x. Okay, and these are two terms. A plus b multiplying 3 is one term. A plus b multiplying x is another term. Now, what do you think is the common factor here? The common factor is a plus b. Okay, because we can divide the first term, 3 multiplying a plus b by a plus b will give us 3. Okay, and we can divide the second term, x multiplying a plus b by a plus b, and it will give us x. Okay, and we'll just go ahead and do so. All right, and when we divide the first part by a plus b, it will give us 3. Okay, so we have a plus b, and then when we divide the second part by a plus b, it will give us x. So what we have is we have a plus b outside the bracket. Okay, from the first expression we have 3 plus, from the first term we have 3 plus, from the second term we have x. Okay, I'd like to make this clear. And that's pretty much how you go, but then I'd like to go over this again. So we're given an algebraic expression, 3 multiplying a plus b plus x multiplying a plus b. Okay, now I want you to assume that you have 3 multiplying a plus b as one term, okay, and you have x multiplying a plus b as your second term. Now, what is your common factor here? The common factor, the thing that would divide 3 times a plus b and x times a plus b, is a plus b. Okay, because if you divide 3 times a plus b by a plus b, you get 3, and if you divide x times a plus b by a plus b, you will get x. Okay, and then what you simply do is you factorize using a plus b, and once you divide 3 times a plus b by a plus b, you have 3. Okay, and then you divide x times a plus b divided by a plus b, you end up with x, and you end up with a final expression, a plus b multiplying 3 plus x. Very very simple, very straightforward. I think we can move on. So example 4. And example 4, it's getting more interesting. Now example 4 says factorize the algebraic expression xy plus 2y plus 3x plus 6. Okay, so this is a straight expression. But then there's something about this expression. We can't just go ahead and find the common factor because there really isn't a common factor. Okay, there's nothing common here. There's no factor that would divide all of them. Okay, but if you notice something, x, y, and 2y have a common factor. Okay, I think we can work with y there, and 3x and 6 also have a common factor. You can work with 3 there. So sometimes you have expressions like this. Okay, some of the constituent terms have common factors, okay, but not all. So you can't go ahead and use one common factor for everything. And what you do in this case is you group them. Okay, so you have x, y, and 2y. I'm going to group this and make this one part of the expression, and then you have 3x plus 6, and I'm going to group this and make this another part of the expression. And now I can factorize what I have in the bracket. Okay, and then what I have, I factorize the first part, and I have y. I can factorize the y x plus 2. Okay, I factorize what I have in the second part, and I have 3x plus 2. And what do you think we do at this point? I think we can factorize further. We can factorize using x plus 2. Okay, and basically I factorize using x plus 2, and I divide the first part. What I have is y. Okay, and divide the second one, 3x plus 2, 3 multiplying x plus 2, and what I have there is 3. So what I have in the end is I have x plus 2 multiplying y plus 3, and that is how you factorize an algebraic expression of this form. So here is our final example, and this one says factorize the algebraic expression 2x squared plus ay minus ax squared minus 2y. Okay, now first thing we want to do is we want to look for a common factor. There isn't a common factor. Okay, I'm looking at it and there is no common factor. How do we approach this? Okay, let's group them. So we have 2x squared plus ay. It wouldn't work. There still isn't a common factor. Now, something about this, okay, we're obviously going to group them, but something special about this is that if we compare this to the last example, the terms were arranged in a very, very fine manner, okay, where we simply just group them, and we had the terms with common factors right next to each other. But sometimes you may be given expressions in this form and you'd have to rearrange the expression in a way collect like terms, okay, before you go ahead with grouping them, okay. And that is pretty much what we're going to do here, because we know if we can't factorize, even if we chose to group them, we can't factorize 2x squared and ay. There isn't a common factor there. But if I bring minus ax squared closer to 2x squared, okay, I can actually group those 2x squared and minus ax squared as one group, and then I'd have a common factor there. And wonderfully enough, I also have ay minus 2y, and I also have a common factor there. Okay, so how to go about doing this? We group them. Okay, so we've grouped them now, and then once we've done that, the next thing we want to do is we want to factorize. So we factorize 2x squared minus ax squared. We can factorize that with x squared, and what we end up with is 2 minus a. Okay, and if we do the same thing with the second part, we factorize with y, we end up with a minus 2. There's a problem there. If we factorize using y, we end up with a minus 2, and we won't be able to factorize further, because normally for us to factorize further we need to have the same thing in the brackets, okay, and we'll end up with a minus 2. But something clever you can do here is, instead of factorizing with y, I can factorize with minus y instead. Okay, something clever you can do here. If I factorize with minus y, I have ay divided by minus y, and it will give me minus a. Okay, and I'd factorize minus 2y by minus y, and it will give me 2. So what I'd have is minus a plus 2, or simply put, 2 minus a. Okay, so if we choose to factorize with y, we'd end up with a minus 2. But now that we factorize with 2y, we have 2 minus a, so we have even terms in the brackets, okay. And now we can factorize with 2 minus a, and what we have is 2 minus a multiplying x squared minus y. Mathematics is so much fun, okay. Makes you feel clever in a way. Yeah, it does. So that's pretty much how you factorize expressions, okay. And this would conclude this lesson, okay. And yeah, bye for now.